Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome back again to this TV Learning Series program. As usual, I'm Teacher Patrick, and this time I'll be taking you through, or I'll be revising with you, for those probably who could have seen this one when you were at school. We'll be together with Unit 5, and then we'll look at the alcohols and ethers. And this is a continuation of the previous lesson of Senior 5. If you've been following, there are some of the things that we talked about. If you remember very well, we talked about the nomenclature of simple alcohols. Nomenclature of simple alcohols. And if you remember also, we mentioned about the classification of these alcohols. Classification of these alcohols. So if I can take you briefly through the classification, because we will continue with the nomenclature of some other branched alcohol. That is part of the things that we are going to look at today. But I just want to take you through briefly about the classification of the alcohols. If you remember, for those who were here, I'm just doing it for those who were not with us in the previous lesson, so that we can go together. So, for those who were present, I said alcohols are classified into 3 groups. They are either primary alcohols, they are either secondary alcohols, or we said they are again classified as tertiary alcohols. Tertiary alcohols. Alcohols. This is for those who were not present. And if you remember very well, we said that this is not the only classification. We said they are also classified according to the number. This is the first classification. We said alcohols are also classified in terms of the number of the OH groups. If you remember the OH groups, we said the OH groups refer to the functional group of the alcohols, the hydroxyl group. So the number of them, how many of the OH groups are attached on the chain that makes that alcohols. For example, we said that if you have only one OH attached to the chain, then that one is monohydric. Monohydric alcohols. And if they are 2, we said they are called dihydric alcohols. If they are 3, they are trihydric alcohols. Or you can say polyhydric alcohols. Polyhydric alcohols. So this is another classification that we talked about in the previous lesson. Probably I can also give some few examples to remind you of what we mean by the monohydric alcohol. We said if you have the alcohol, and if I give an example of the simple alcohol, maybe methanol, this is only one OH. If I give an example of ethanol, CH3, CH2OH, this is only one alcohol. So that is, we looked at them. So these are monohydric alcohols. We may have other examples. If there are 2, for example, you have CH2, CH2OH. So you have 2 alcohols there. So you have this, and then you have this one. Those are the 2 OH. So that one is referred to as a dihydric alcohol because it has 2 OH groups. Then the tri, that's where you have the 3. CH2, this is CH, you have OH, and CH2, you have another OH. So you have 3 alcohols. You have this one, you have this, and then you have this. Those are 3, tri. So it can be even tetra, penta, so they are depending on the number of the alcohols. So these can be trihydric alcohol or pori. Pori means many. So that is what we are referring to. Coming back to this form of classification, the primary, secondary, and tertiary. If you remember very well, we said that these ones, they are also, we can use 2 ways. There are 2 ways of how we can use to classify this. One, we said, for example, if you have CH3, CH2, and OH, what you do, look at this carbon that contain the OH group. When you look at that OH, that carbon, it has, and if you find it has 2 hydrogen atoms, these are 2 hydrogen atoms attached on this. So this carbon contains this, and then these 2 hydrogen atoms. So that is a primary alcohol. If you have, for example, this is what happens. You have this CH2, you have OH here, and then you have CH3. Look at this. The carbon containing the OH has got only 1 hydrogen atom. So if it has only 1 hydrogen atom, this one becomes a secondary alcohol. So if you, for a tertiary alcohols, this is, I'm just giving an example of these, the tertiary alcohols, CH3, and then you have the OH. This is an example of the OH. The OH is here. So when you have the OH, you look at this OH, there is no hydrogen atom attached on this. This carbon containing the OH doesn't have any hydrogen atom. So you look at the structure, you can easily tell this is a tertiary, this is a primary, or this is a secondary alcohol. So this one becomes tertiary alcohol. The carbon containing the OH doesn't have a hydrogen atom. That is a tertiary alcohol. Then we also mentioned again on this one that you can use the number of alkyl groups. Alkyl groups are obtained from alkanes when 1 hydrogen is removed. For example, if you have methane and minus 1 hydrogen, this one becomes methyl. This is a methyl. And generally, we call that one an alkyl group. So this one is referred to as alkyl group. So that is what you look at the number of alkyl groups. The alkyl groups can be either methyl, can be ethyl, can be propyl, can be isopropyl, and so on. So there are many of them. Look at them. How many are there? Look at this carbon containing. How many alkyl groups are there? So you'll see there is only 1. And if you find it is only 1, that is a primary alcohol. If there are 2, you have this one, that one becomes a secondary alcohol. If there are 3, you have this one, and you have this. They are all attached on this carbon containing the OH. That becomes a tertiary alcohol. So that is briefly what we talked about last time. Today, we are just going to look at the nomenclature of the branched alcohols. Branched alcohols. So we look at the nomenclature of branched alcohols. Branched branched alcohols. So you may have an alcohol. For example, let's start right away. We have CH3, you have CH2, OH, and then you have CH. Before we have that, this is the hydrogen. So what class of alcohol is that? So you have to first look at the class. If we are using the tertiary, primary, and secondary, you will be able to tell that this one, it has the carbon, this carbon containing the OH has 2 hydrogen atoms. Automatically it becomes a primary alcohol. So when you are naming primary alcohol, the carbon containing, remember the rules of naming these organic compounds. We are not changing the rules. What we are only changing is the functional group, so that the rules that we looked at when we were looking at the alkanes. So we are only changing the functional group. So we still maintain the rules, the IPA rules. So whenever we are naming primary alcohols, this carbon here becomes carbon number 1. So you look for the longest chain. So this will be carbon number 1. And if you are looking for the longest chain, 1, 2, 3, or it can be 1, 2, 3. So those are the longest chain that we have. We have this 1, 2, and 3. That is the longest chain. So you see the methyl group, this methyl group is attached on carbon number 2 of this alcohol, of the longest chain. So the longest chain takes the base name from the parent alkane. From the parent alkane. So the parent alkane with 3 carbon atoms is propane. So that means that is where the name will be derived for this alcohol. So we start with, as usual, as the names of these alcohols and even other compounds like alkanes. So we start with the branching. We say 2-methyl. It is indicating that the methyl is attached on this carbon number 2 of the longest chain. And the longest chain has 3 carbon atoms. So this is 2-methyl propan 1-ol. So you need to mention the position of that OH. We can use another example. Let's give another example. CH3, CH3, CH2, OH. This is CH3. Still, what you need to do is to name the number, the carbon atoms. And you have to remember, you need to look for the longest chain. So if you start from here, this must be carbon number 1, because this is a primary alcohol. This is carbon number 1, number 2, number 3, number 4. So that is the longest chain. Now, on carbon number 3, we have 2 methyl groups. And which is the longest chain? The longest chain has 4 carbon atoms, so it is derived from butane. So it will be butane, that is the parent alkane. So this one will be, now you have 3, so according the rules, if you still remember the rules that we use, this one is mentioned twice. So this will be 3, and because they are 2, then you have to use that di to represent the 2. Di means 2. Dimethyl. Dimethyl, what is the longest name? That means it has to be butan 1-ol, because that ol is the one that makes it the alcohol. If we are coming, we come back to, for example, to naming primary and secondary alcohols. We are naming primary and secondary alcohols. For example, I will give an example of this. This is a secondary alcohol. Those are primary alcohols. So this is a secondary alcohol. What makes it secondary? Remember, we said the carbon has 1 OH. So in this case, OH does not take position number 1. So you have to, either coming from either side of the chain, you have to count the number of hydrogen. You have to number them as we've been doing. 1, 2, 3. So you know the 2, this one will be on carbon. The OH is on carbon number 2 of the longest chain. So the longest chain is derived from an alkane that has 3 carbon atoms. And you remember the name of that compound? Perfect. That is propane. So you have propane. So it is now, you can say propan 2 or. Or you can say 2-propanol. 2-propanol. What does that mean? That the 2, this 2 represents the position of the OH. Or propan 2, this 2 is the position of the OH on the longest chain. So that's how we name the secondary alcohol. So we may have the same method that we use to measure, or rather we use to name the secondary alcohol is the one that we use even to name the tertiary alcohols. Let's take an example of this tertiary alcohol. We said tertiary alcohols do not have any carbon atom, do not have any hydrogen atom attached on the carbon containing the OH. So the same thing that we can do, just number the carbon atoms that makes the longest chain. So you have, this is number 1, number 2, number 3. Even when you start, you can even number it in this way. You can still number it, or that is the only 2 options. We have this one, or we have this one also. Or whichever you take, the longest chain remains 3 carbon atoms. So what does that mean? We have a methyl group on carbon number 2, and this is the methyl group, and then we have even on the carbon number 2, that is where we have the OH. So this one becomes 2-methyl. 2-methyl. The longest chain has 3 carbon atoms, so it will be propan 2-or. Or you can say that 2-methyl 2-propanol. 2-methyl propanol, as we did like this. So that will be the longest chain. That will be the name of this alcohol. All alcohols, remember, end with or. That is, if you can see properly. Right, let's look at something else. And this is about the isomerism. Let's look at something else, which is isomerism. I hope you still remember what we mean by the isomerism. But we are just looking at the isomerism in alcohols. Not because we had looked at these ones even before in alkyl halides, looked in alkenes, in alkanes, in alkynes, in also we had looked at this one. So we are just looking at this isomerism only in alcohols this time, of alcohols. So 3 types of isomerism exist. 3 types exist in here in alcohols. 3 types exist in alcohols. And can you suggest what these types are? Well, let me help you. So we have chain isomerism. We have also position isomerism. And then we have functional isomerism. Functional isomerism. All these fall under structural isomerism. So when we're talking about the chain isomerism, let me just give an example. If we are talking about the chain isomerism. So these isomers differ in terms of the chain, or if they have branches. So this is CH3, CH2, CH2, OH. Can you give the name of this compound? Like this is propan 1-ol. Or we said can be 1-propanol. That can be the name. Now, this compound is isomeric to this secondary alcohol. Why do we say they are isomeric? They have the same number of carbon atoms, the same number of hydrogen atoms. Therefore, that's why we say they are isomeric. Look at the number of carbon atoms. 1, 2, 3. 1, 2, 3. Look at the hydrogen. 3, 5. This is 7, 8. Look at this one. This is 3, 6, 7, 8. Oxygen, the same. So these compounds are isomeric. So this one is 2-propanol. 2-propanol. So this is what we mean by the chain isomers. Chain isomers. No, sorry. I beg your pardon. These two compounds, I think we are starting with, sorry, we'll come back to the chain isomerism. This is position. This is position isomerism. So we'll come back to the chain. This is position isomerism. So we have these two. The position of the functional group. This is on carbon number 1. This is on carbon number 2. So we can also mention right away, we mention the chain isomerism. If we have this compound, CH3, OH, and then we have CH2, 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 OH. 1, 2, 3, 4. 1, 2, 3, 4. How many carbon atoms do we have? They are the same number of carbon atoms. How many hydrogen atoms? If you count the number of hydrogen atoms, they will be the same. So this compound, this 2-methyl, this is 2-methyl propan 1-ol. 2-methyl propan 1-ol. And this butane, this is butane 1-ol. This is a chain. It is branched. So these are called chain isomers. These are called chain isomers. Then the last one, we can talk about the functional isomers or the functional isomerism. Where do we have that type of isomerism? Well, I've said in the alcohols, what kind of the isomerism in there? So in the functional isomerism, so we'll have this example. We'll have CH3 or CH3. I just want you to look at these compounds. CH3, CH2, OH. When you look at these two examples I've given, this is ethanol, and this is methoxymethane, or dimethyl ether, or dimethyl ether. How many carbon atoms? Isomerism have the number of carbon atoms, the number of hydrogen atoms. So the number of atoms have to be the same. They only differ in the arrangement. The atoms differ in the arrangement in space. 3, that is 6 hydrogen atoms. Carbon atoms are 2. Then oxygen. Come here. Carbon atoms, there are 2. How many hydrogens? 3, 5, 6. Oxygen. This is an alcohol, this is an ether. So the alcohol, then ether. This is another functional group. So these compounds are isomeric. So that is the function, that is the isomerism that we are supposed to talk about. And lastly, but not least, we are just going to look at the physical properties. We just look at the physical properties of these alcohols. How do they behave physically, not chemically? And we start with the boiling point. Look at this. I just want you to look at this chart. Compared to the alkanes, with almost, look at this alkane, this is ethane, and this is methanol. The boiling points differ greatly when you compare these compounds. Look at the propane, and then the negative, this is negative 42 in degrees Celsius. When you look at the ethanol, this one has more carbon atoms, this has less carbon atoms, but this has, the boiling point is very high. Why? It is because alcohols have hydrogen bonds. They form hydrogen bonds. And those hydrogen bonds means that there are extra bonds that will need to be broken. This is an example of an alcohol. So this one will form an hydrogen. This is a hydrogen bond that will be formed with another alcohol. So this is the extra. When these molecules come together, more energy will be required to break these extra bonds. So this will be a hydrogen bond. That is about the boiling point. And then even these hydrogen bonds affect the solubility. So we're talking about the boiling point. That is number one. We can also talk about the solubility of the compounds. You say solubility in water. They are highly soluble in water. And the solubility is also because of the formation of the hydrogen bonds. So if you have the alcohol, this is the general alcohol structure. So this one will form a hydrogen bond with water. So compounds that form hydrogen bonds with water are said to be soluble in water. And because of the hydrogen bonds, these alcohols mainly exist as liquids, and with high number of carbon atoms, they can also exist as solids. So I said, last but not least, before I wind up, I want you to answer these. Just take note and write these questions in your books. And then you'll try to answer them. So this is your homework. So you just try to answer those questions. Number one, given the following compounds, that is compound A, CH2, CH2, OH, B, CH3, CH2, OH, and C, CH3, CH2, you have C, CH3, OH, and then D, you have CH3, 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 OH. Identify the type of isomerism in compounds A to D. That is part 1A. Part B, describe how the boiling point compare with those of the boiling point of alcohols, compare with those of alkanes. With that, I thank you so much for listening and watching, and we'll be together next time. Goodbye.